Welcome back to Connect and Transform. In this video, we're continuing creating a text comparison tool for the web. Let's take a quick look at the pseudocode again. I realized I missed a condition in while loop number 2 that is pretty important. So all the logic that we've written so far is the same. It is correct. So for example, I have this note here that we break out of while loop number 2 when both look-ahead pointers are exhausted, and that's correct. But keep in mind that we would actually be breaking down here after we're checking the conditions, not at the head of the while condition. So the thing we need to add is we need to say, just as both look-ahead pointers exhaust, and before we break out of the loop. Okay, so under that condition, so what does that mean? So remember that we're comparing, for example, the left-hand processing pointer to the right-hand look-ahead pointer, and at the same time, we're comparing the right-hand processing pointer to the left-hand look-ahead pointer. So if both look-ahead pointers exhaust, that means we're left with a line on the left at the processing pointer location, and then also a line on the right file at the processing pointer location, neither of which exist in the other file, at least when looking in a forward downward direction. So we need to consume those lines. So under this condition, we'll create a left-only line and a right-only line. And so that's it. This is the condition that I didn't think of in the last video. But with this, once all of this, well, really the whole thing, but definitely once all of this is built, and in fact, we don't even really need some of these, but I think this is an important one. I think rule 1, which we've already done, is important, and I think rule 2 and maybe rule 3 will be important. Once we have those, we'll have the bulk of the files here matched, because I know that there's only a few changes to the files. So for example, if I pull up this comparison, we see a lot of white here, which means a lot of these files are exactly the same. That would be rule 1, but we need to have the right offset, which means really we need to implement things like this, where it detects groups on one side or the other. So if I want to process the whole file, we really need to be done with all the rules. But if I'm just looking at like the front of the file, okay, that's rule 1. So what we see is that in these particular files, we do have to implement detection of this condition where it's present on the right, not present on the left. We have to implement that before we can actually advance and consume more of these lines. Once we have just those 2 rules in place, we would be able to consume the first 46 lines, 46 logical lines, I guess, of the files. But we'll do what we can piece by piece. So back to this file. So now that we kind of have in our minds that additional scenario, let's head back into our code here, into the text compare arena, and let's look at this second condition, if they're equal after trimming white space. So that's basically just going to be a copy of this line, and we're going to say else if. Okay, so again, this was basically a copy. Actually, there's one more thing though before I do that. It occurred to me that it might be useful to know the specific line number for each file left and right that was actually consumed. So I think right here in this text where it says rule 1, I'm going to say, so remember we're on the left line node, so I'm going to say L for left, so L dash, and then I want to pass in the line number, which will be this same object but .id, because remember that up here, when we're creating the objects, we gave ID to be equal to the iterator, which is also the file line number with 0 index. So in this case, we're now saying the rule number, and then we're saying which side file it is, and then the file line number with a 0 index. And then maybe we'll keep our colon space at the end. And so I'm going to copy this down into the right-hand side. I'm going to change L dash to R dash. I'm going to change left to right and left to right. Okay, so now I think I'm ready to copy this group. And we'll do a demo in just a minute here. We're almost to that point. So for rule 2, we are trimming white space, which would mean .content.trim, .content.trim. But if you remember, we already replaced some white space, tabs, with arrows. So I'm just going to copy this, replace all, so that I grab that arrow character. And right before we trim everything, it could be after as well, but I'm going to put it before. And I'm going to say, look for the arrow character and replace it with nothing. So this was a little bit of extra work that I created for myself, just in the order of operations here, but not too bad. Okay, let me save that. Oh, one more thing. We're going to call this rule 2. It doesn't really matter what the number is. I just want them to be different for debugging purposes. So I'll save that. And then let's go back over here. I'll refresh the page and then reselect the files. So I've named it left.svg and right.svg. Okay, must have a typo. Line 88. Oh, yes. And same there. Must have done something weird. Okay, so we'll save that. Refresh. No errors. That's a good sign so far. So left and right. Okay. So now we see a lot more lines that have matched. Oh, the styling is not different. Let's go back here. So remember that we specified our class name to be whitespace trim instead of exact. So we're going to do that. Save. Refresh. We'll have to reselect our files, left and right. Okay, so there we go. So now we can see in blue, which almost looks purple to me with the applied opacity, we can see the different rules occurring. So that's one rule down. Let's do maybe one more rule. I'm going to copy that whole group. Okay, so next in line is if they are equal after removing all white space. So for that, I'm going to use regex. And actually, well, we might keep, yeah, we're probably still going to get rid of the tabs because we don't care if the tabs are different, really. Okay, so we'll keep this, but then instead of .trim, that'll be .replace, and we'll do the same on the other side. And we're going to have some regex. And so that's going to be /s, and then /g for the global flag, and we'll replace it with nothing. So that, I believe, is saying that we're going to replace all white space. Okay, and then we're going to call this rule 3, and then make sure that our class names match white space remove, white space remove. So we'll save that. Now, I don't know that we're going to hit this condition yet. We might need to create some additional rules before we ever hit this condition in these particular files. Yeah, so I don't see any errors, but I also don't see that this was able to trigger. Let's move forward a little bit more. Okay, so now let's look at if they are nearly equal. And so I'm thinking that I'm just going to copy this with no white space and no tabs, I guess. And then I'll probably implement this to start as some form of substring. Okay, so yeah, let me just copy that. So then we would say if that thing dot substring and I'm not sure. So maybe we'll just look at the head of the line, and maybe we'll just look ahead some number of characters. So for now, let's make another constant for the number of characters that we'll be looking ahead. So I'm going to call this so it's going to be a length at the beginning of the file that is a substring for matching. And let's say that we make that, I don't know, 8, 6. We'll change it. And, you know, I don't know what to call it. I'll probably change that name. I'll almost certainly change that name later. So this will start at position 0. And we want to make sure, like, if our line is less than the 6 characters, we're only going to go the minimum of either that constant value or the length of the line at that location, which I guess would be just this dot length. This is going to be a long line of code. Okay, so we have dot substring, which goes, oh, it goes further, it goes to there. Okay, so we'll copy that, and then we'll scroll over, paste it here. Now we do have to modify this side from left to right. I think that might do it. And then we're going to call this rule 4. Again, it doesn't matter what we call it. And then we'll give it a class name of .altered, and that is important. So we'll save. Now let's just refresh and see if we've at least made any typos. So we'll choose our files again, left, right. Okay. It's interesting that it says those are altered. I'm just scanning it briefly, trying to wonder why it thinks those are altered. Okay, so for example, and I know you can't read the line numbers, but look at this line here. So it starts, if we're ignoring tabs and white space, it starts with graph data dot, and we look at this one, and it starts with graph data dot. So that's why it picked that one. When we write more rules, those might match these line contents with a better rule. Yeah, so if the ordering of the rules matters, I might have to put while loop number 2 in a different location. So I'll have to, I think we'll cross that bridge in another video. But I'm just kind of scanning some of these. Okay, yeah, right, it does make sense because here offset is 0 and here offset is 60. So it is finding things that are not exact matches, but they're close, at least in the beginning, ignoring white spaces and tabs or arrows. So the rule is functioning, but we may need to change the precedence of the rules later on. Let's take another peek at our pseudocode. Actually, let's take a quick peek at this, right? So if we look at that particular one that matched, yeah, it's interesting that it matched a 0 to a 60. Oh, but I guess these 4 green lines are not present in the other file. So I think it might have actually matched this line here to this line here, just because we haven't finished creating all the rules yet. But we do have these 4 rules done. So maybe I'll add the second while loop, and then we'll just call that good for this video. So for now, before we do any special ordering of the rules, I'll just say else, and then we'll have while. So this is while loop number 2. And this particular one, the intention is that it just runs until I basically say, break out of the loop. And so first we're going to have, in fact, maybe I'll copy some of this into there. I mean, I guess I'll just write the break in place, and then we'll address it when we actually write that code. And then of course for this one, just as both look ahead pointers exhaust, before we break out of the loop, it was implied that we would break after that, because these 2 lines will only run in the condition that leads us specifically to break out of the loop, which is that both look ahead pointers are exhausted. Okay, so we're going to have some if condition here, and then there's some if condition here. So this will be if left discovery pointer is equal to the number of objects in the left minus 1. I believe maybe it's just if it's equal. But I think that's right. Actually, so each time the while loop iterates, we have an if condition, or else if condition, whatever. And then we're going to be advancing the left and right processing pointers, I believe. And then we're going to be checking and so if each of these are exhausted, so and right discovery pointer and again, I might be off by one there. We'll correct it later. So because both files can be different in length, we can't just blindly increment these pointers. I'm trying to see if I wrote that in here. Right. Okay. In while loop number 2, when no line is produced, and so that is, yes, that is what we're talking about, because when a line is produced, we're breaking out of the loop anyway. So if we ever get to this point, no line was produced, and the pointer is not exhausted. So that's what this if statement's going to be. So if left discovery pointer is less than that, then we're going to increment it. Same for the right. That's not the right thing. Okay, so we're only incrementing these pointers in this part of the while loop under these conditions. And then we have our exit condition, so we still need to produce these. And I don't know, maybe I'll leave these comments in here. Maybe they're helpful, maybe not. But this is going to be some if conditions. So let me just put that in there. Okay. I think that's right. Okay, and we've got our class names here, and we've got examples of producing left and right. So let me just, oh, now these two have some special conditioning because they're each going to have a loop inside of them because they are producing lines. So if I go back over here, those if statements only run after we've determined the entire range of one of these groups that's only on one side or the other. So then it needs a loop to go through each of these lines and produce them. So we're going to be comparing, for example, the left look ahead to the right. Well, okay, so if lines only exist on the left, then the left would be the look ahead pointer being compared to the right hand's processing pointer. And in this case, we're looking for an exact match. I'm kind of thinking in my head, I'm like, do I want to do trim? Do I want to do anything else? Yeah, maybe I want to do trim. Okay, so let's just start writing something out. We'll modify it later if we need to. So if left file line objects at the discovery pointer location, and then if we want to trim, I don't think we want to do full white space remove because now we're like really modifying the meaning of the line, but I think this is maybe reasonable to do. And we can always change this later, but I think I'll begin this rule by saying that we're not going to consider tab characters or leading or trailing white space. So if that is equal to, I'm just going to copy this, we'll modify it, change left to right, left to right, but this will be not the right discovery pointer, but the right processing pointer. So if that's true, then we're going to have a loop. And in that loop is where we're actually going to be creating lines. And then we're also going to do line iterator plus plus after that. Oops, wrong one. Okay, and then we want to advance the left-hand processing pointer to be equal to the left-hand discovery pointer. Okay, so what is this going to be? So maybe we'll say P for pointer. So that's going to start at the left discovery pointer. And it's going to go, no, it's going to start at the processing pointer, which is now behind the discovery pointer. So it'll start at the processing pointer, go up to the left-hand discovery pointer. That will give us the correct number of iterations in this loop, I believe, for creating these two elements. So, kind of debating when to copy and paste here into the next group. But basically setting this up for the opposite comparison as well. Okay, and then here left would change to right and left would change to right. Line iterator is the same. Okay, so now we just need to modify this in this one. So instead of left discovery pointer here, this is going to be left processing pointer, and then instead of right processing pointer, it's going to be right discovery pointer. Okay, so now we just need to create our actual elements. So I don't think we've done an instance of empty yet. Well, I guess we haven't done an instance of only or empty, but I'll start with, we'll just copy this and then we'll modify it. I'm going to keep those notes there for now so that I remember what the class names are. Okay, so it's still line left, but instead of altered, that's going to be only. And then here, this will be .empty. Okay, I guess I am putting left and right in all of these. I guess it's good to have just in case. And this would be rule 5. So this would change to P, which is our pointer location for both of these, for all 4 of these. So we're grabbing the display content based on iterator P, and we're grabbing our file line number based on iterator P. Now remember that we're creating an empty right line, but first I'm going to copy this, and and I'm going to paste this down in the next one, because in the next one we are creating a right line, but then we're going to create an empty left line. Okay, so back up to here, we're creating an empty right line. So I'm going to remove that inner HTML statement, and then here, we're producing an empty left line. Oh, let me order this the same as everything else. So we're doing left first and then right, and then we'll get rid of the inner HTML there. And then we need to swap these two, so that becomes empty in this condition, and this becomes only. So let's just double check ourselves. So the two that are only have inner HTML. The two that are empty do not have inner HTML. All the iterators here are based on P inside the loop. We're updating our pointer. We're updating our pointer. Oh, actually, well, yeah, that's the processing pointer. So that is very important to set before we break. For a second there, I thought we were setting the discovery pointer, which would not matter as much because, oh, that's right. Every time we set the processing pointer. Okay, so in this particular case, we don't need to set the discovery pointer because they're equal. But we do want to keep in mind that we don't ever want the discovery pointer to lag behind the processing pointer. So it's not an issue in these two particular scenarios. But for example, here, we're advancing the processing pointers. So we should probably also advance the discovery pointers. And I'm going to follow this same logic over here. Down here, this was just kind of an edge case where they were always in sync, but I think it's more proper to do the assignment this way. So what are we doing? We're setting the discovery pointer equal to the processing pointer after we've incremented the processing pointer. Okay. So let's save that. Let's do a quick check, and let's just see if we have typos. Let's see how far we are off. So we'll select left, select right. Okay. Oh, I need to do dot something, I guess, and that's on line 143. So I may have copied and pasted a certain mistake. Okay. So this needs to be dot content. I'm surprised that that happened. I thought we copied that from here, but yeah, that has content. So as always, typos, copy and paste mistakes, I'm not immune to them. And there we go, another typo in the works. All right, so we'll save that. Let's go back here, refresh, choose our files again, see how much progress we did or did not make. Okay. So we don't have any errors necessarily. Now I can see here that's rule 1 in green, rule 2, and rule 4. Speaking of which, I may not have finished updating some stuff. So this is rule 5. This then is going to be rule 6. Yeah, I think this is all okay because this is in an else condition, so it would only run after these things would have been advanced. Let me save that. I may have to just think about this and come back to it. Okay, so it will have reached a point where this will trigger on two lines that don't match. The discovery and processing pointers on the left and right, at least initially, should be exactly the same. And we copied and pasted that, so that should be the same. So we're starting at left processing, going to left discovery, but only after this condition is true. And in the meantime, this would be true, so we'd be advancing. Oh. I don't think this is right. I'm advancing the wrong pointers. Okay, so that would explain it, I think. I'm surprised that we didn't get stuck in this loop, though, because how would we ever have broken out if we're not advancing the discovery pointer? So that's a mystery. Anyway, in this condition, before we break out, that's when we want to update our processing pointers, and with them, the discovery pointers. Now here, we want to update just the discovery pointers, I believe. I'm still confused as to how we didn't get stuck in this loop. So we're going to be incrementing our discovery pointer until our discovery pointers reach the end, and then we're going to be advancing our processing pointers before breaking out. That is going to haunt me like forever. Now, the only way I could see that happening is if we just never hit this condition. But anyway, I'm going to save and refresh. As always, it's perfectly explainable. Oh, there we go. That's more like what I was expecting to see. I still don't know why we didn't get stuck in the while loop before. But let's do a quick comparison of Notepad++. So we see a lot of similar things. So let's look specifically at the content. So this is 4 lines. So we have a line here, transition opacity 0.3. We have 4 lines here. Then we have a closing style tag. Let's look at our browser. Transition opacity 0.3, 4 lines. Okay. So we don't have our closing style tag. So we are skipping a line. Which I thought it would automatically get picked up by the next iteration of the loop. So I'll have to look at that. But in any case, we can see, oh, good. We can see this here, rule 5 in red. Yeah, let me go through all the rules and see if we hit them all. So we've got rule 1, for example, there. Rule 2 there. So 1, 2, 4 in orange here for... and then we got 6 in green. So we got 1, 2, 4, 6. And if I scroll down here, rule 5 in red. So the only thing I have not necessarily seen yet is rule 3. Yeah, let me keep scrolling down. Let's just see how far this goes. Okay, so something isn't quite right in here, because there's a lot of offset happening. Let's see. So we've got series labels, pi ring, highlight index. unhighlighted index. Oh, maybe that's right. I still haven't seen rule 3 trigger anywhere. Maybe that's just a function of what's in the file. Okay, and clearly we are missing some stuff. Yeah, so if we look, I know you can't read this, but if I look here, it says Rule 1, left file, line 871. And then if I look at the very next one, Rule 1, left file, line 878. So we do need, if I go back to the pseudocode, we do need these while loops number 3 and 4 at the very least. But real quick, I just want to look up and see what rule 3 is, because that's the one I never really saw. Oh, that was removing all white space, whereas 2 was trimming and removing tabs. Let me do a quick search. So I'll do find rule 3. Yeah, I don't see any instances of it. So maybe I'll have to edit one of the files for the next video and show that. But I think for now, we're going to write out these two, and then we'll call it good for the video. Let's see. So we've done these two. Oh. Right. So we did that one. We did that one. So really the only things we've not done is this scenario here, and then while loops 3 and 4. I'll just keep going. This will be a long video, I guess, but we're making progress. So here we're going to be producing dot only. So let me think. I'm not sure I want to copy that from there. I'm just going to copy it from up here, because otherwise I'll have to edit the iterators from P to something else. I'm just thinking about what the pointer values are at this point in time, and whether this should be before or after the increment. I think it should be before. So we're going to be creating line left only. Oh, right. And so we're actually creating 2 lines here, not just 1. Now we got to remember to do our line iterator. So we're going to be creating an initial line, and I need to add in the right-hand side. And then we're going to be creating a second line. And so this will be line right only, which will contain content. And we're going to call this rule 7. I think we're on 7. So really this is like 7a and 7b. Let's see, processing pointer is correct, processing pointer, correct. Okay, so now I just need to copy in some examples of empty lines. So I'll copy this left empty line, which will correspond with this right line. And then I'm going to copy this right empty line, which will correspond with this left line here. And let's see, rule 7, rule 7. We're iterating the line twice. I think that'll do it for that condition, and then all that should leave is while loops 3 and 4. Let me go ahead and save. Refresh. Left line, oh right, we're creating 2 lines. It's always the dumb stuff. So I guess I'll make that a variable. And I could have called it left line A, left line B, whatever. This was fast enough. Oops. Okay, so we're going to select left, select right, Still not perfect because I'm still not seeing that closing style tag, which should be somewhere in there. Because I can see here rule 6 R12 and rule 1 R14, so clearly we're skipping a line there, so I'll need to look at why that is. But we just added rule 7, I believe. Let's see. So let me search. So if we do rule 1, we've absolutely got rule 1. Rule 2, we've got. Rule 3, I don't see anything. Rule 4, yes. Rule 5, there's just a couple. Rule 6, yes. And rule 7, we just added. Now, is rule 7 green? Yes, rule 7 is intended to be green. Okay, so okay, it's interesting that we've got a lot of like rule 6, not a lot of rule 7. Now, am I skipping any lines here? Let's see, 1169, 1170, 56. Okay, so we're missing a line in there, and we're missing a line in there. So I think we're very close. We probably just have one place where there's some kind of off by 1 issue, but it's very, very close. And then the other thing, okay, so let's go ahead and just add our while loops at the bottom. That's not going to solve our off by 1 issue because it's not applicable at that by the time we get to that point. Let me just make sure I'm in the right place in the code. Yes, so right after that while loop. Okay, so if lines only remain on the left. So this would be if left discovery pointer is less than the number of lines. Let me just double check by scrolling up here. Yeah, so here we're saying left processing less than dot length. Oh, the other thing is we might only want to increment this kind of similar to up here. Okay, let me copy that. And then we're going to swap these. So this would be left processing pointer. Okay, so that's the first condition. And so this would then be right processing pointer less than that. I think that way we restore the we retain the position of our left and right processing pointers, and then this would be processing pointer. So that's while loop number 3, and then we have here while loop number 4. Okay, so in this scenario, the left-hand side will be creating some elements and then doing that. And the right-hand side we'll be doing this. So that'll increment until we break out of that final while loop. So as far as producing the actual elements, in the first one here, while loop number 3, we're going to be producing left only and right empty. And maybe for good measure, I'll just paste some of the pseudocode in. And this is really .right.empty. And left.empty. Okay, so first up here, doing left only, that would be roughly equivalent to this. And then we're going to have a right hand empty. Oh, I guess I could have just copied both lines, but both groups in a row. Now let me check the iterators here. So that's based on the processing pointer. I think that's correct. And then here, left and right. Okay, I think that's right. Yeah, so we got empty, we got only. Okay, so let's modify our rules. So that'll be rule 8, and this will be rule 9. Save it, refresh, choose our files, left and right. Okay, looks like we are stuck maybe in a loop. So there were a couple things we changed. We changed this, and we changed these. Now these are incrementing unbounded. So they are guaranteed to exit. So I suspect the problem has to do with this. So if it's less than this minus 1, so it'll only ever increment to that thing minus 1. And if we go up here, oh, we're looking at the actual length. Okay, so in this case, we just want to say that, I think. So let's save it. I'm going to copy that because I think this tab is pretty much frozen. Go there. Choose our files, left, right. Okay. So let's look for rule 7. There's a couple. Let's look for rule 8. There's nothing. Rule 9, nothing. So I suspect that we're still off a little bit. Yeah, we still got R-1176, R-1178. Let me try selecting them in the opposite order and just seeing what changes. I still don't see rule 8 or 9 triggering, which is interesting because they are different length files. Yeah, rule 8, nothing, rule 9, nothing, rule 3, nothing. But we're making good progress. I think we're going to end the video here. I just want to bring this up and then pull this up again and just kind of show that generally speaking, they're pretty similar. There's just a couple more little tweaks to make, and then we can get further into the UI and interaction after we've got more solid grouping and classification. Thanks for watching.